And the topic of today's lecture is project schedule management. And really, the name says it all. So in this case, we're going to concern ourselves with how to make sure that the project is completed on time. So we're going to have to put together a detailed plan on what's going to happen, how is it going to happen, when is it going to happen, with some contingencies and so on. We're going to understand how tasks are identified from the work breakdown structure. We're going to see ways of relating of those tasks to each other. We're going to try to build a practical and meaningful project schedule. And in the end of the day, the purpose of this process and this knowledge area, really, the processes within this knowledge area, is to create a time baseline so that we can carry out our project against some baseline that we can then measure and control. Increasingly, we're going to see iterative scheduling, so changes in the life cycle models from waterfall to more discovery-based, like agile or spiral model. We're going to look increasingly on-demand scheduling based on the theory of constraints by Eli Goldratt, I think the name of the gentleman, and pull requests. So again, this kind of is related to the agile model. And the way we're going to be doing the scheduling for our project is going to be affected by many things, including but not limited to what life cycle are we subscribing to, whether it's the waterfall or any of the discovery methods or life cycles, whether we have sufficient resources, and how we're going to deal with the resources unavailability, how big is our project, and what kind of support can we ensure for our project. And in essence, what we're going to be focusing on in this knowledge area is taking the work packages that we had developed before last week, and we're going to turn the deliverables from the work packages and turn them into activities. If you recall, work packages give you deliverables, and we're going to have to complete some activities in order to arrive at those deliverables, and that's what we're going to be doing in this knowledge area. Once we find all of the activities and document them, we can start sequencing those activities so that we put together a meaningful activity sequence. So that's nice. They are sequenced in such a way that they correspond to how those activities would be done in the real world, according to some technical specifications and some technical and managerial objectives. Excuse me. Now, once we sequence the activities, then we're going to figure out the amount of resources and amount of time really that we're going to require for the activities to be completed, and that will allow us to figure out what's the activity duration. Now, once the duration is estimated, we should be able to develop an ideal schedule for the project at hand. Obviously, it may not be realistic at that point, so some of the activities will have to be compressed or optimized so that the resources are adjusted, or at the end of the day, we would end up with something that is more realistic. Now, the schedule that is produced through these steps is approved by the managers or the sponsors or the guiding committee or whoever it is in charge of the project approvals. And once it's approved, we finally arrived at the time baseline. And the baseline forms, the reference point against which schedule control is carried out to see whether the project is ahead of the schedule or behind. What's the forecast for the schedule completion dates, whether it's according to within plan or not. Would the project would be able to meet the deadline if it continues at the same pace as it is. And earned value management comes into play in here quite a lot. There are 6 processes in this knowledge area. We have 5 of them in the planning. So we plan the schedule management, define and sequence activities, estimate their durations, and develop schedule, after which we control schedule. So controlling schedule means that we're able to end up with some successful project completion, let's say. Now, as always, we're going to start with some subsidiary plan, a mini plan that will inform the project team how the schedule would be made in this project, who will participate in making it, what template documents are supposed to be used, what unit of duration of time measure is to be used, what kind of thresholds for variances would be used, who would approve it, who would review the project, what's the frequency for the schedule control, and so on and so forth. All these categories of topics should be included in a subsidiary plan called schedule management plan. And that plan will provide guidance and direction on how the project schedule should be created and then managed. Really, we have 4 inputs into this process. We have 3 tools and techniques, and we're only going to output 1 document, which is the schedule management plan. Inputs into this process include project charter, which provides the high level 30,000 feet overall timelines, or the project deadline, maybe with some key milestones, overall scope of the project, things that would have a bearing on how the schedule of the project is created. Now, charter may also have some information about the unit of measure of time, some of the tolerances in terms of the deadline, whether we can go plus or minus 6 months or 6 hours from the deadline. So that's going to make an impact on how the project schedule is going to be made. The project management plan rather, provides inputs like scope baseline together with the work breakdown structure and work breakdown structure dictionary. Those 2 documents provide a list of deliverables which are required to create a list of activities, and those activities are going to be sequenced to develop a meaningful schedule. Some additional documents may include project management plan components, may include risk management plan, and risk management plan would inform the project team on how on dealing with the schedule associated risks, which would also have the bearing on the schedule management plan. If we have access to scheduling software, we should use it. And obviously, if we have it, we're going to use template forms, reporting tools, and so on from previous projects if we have it available to us as well. For tools and techniques for this process, we're going to rely on expert judgments. So any individuals or groups of people who have expertise and knowledge that would contribute to the development of meaningful and practical schedule management plan should be consulted for this process. And the list includes the project management office, the experts in scheduling, other project managers and project sponsors that could have done the kind of project in the past, some of the key stakeholders that have experience with scheduling, or maybe even industry or domain experts. We're going to need to analyze some data in order to figure out what development life cycles, what kind of methodologies and alternatives would be best for our project, to review alternatives of scheduling tools, the scheduling methodologies, the ways, the resources, and durations are to be estimated. All of this would have to be decided. So, and the decisions should be made based on some meaningful data. So that's why we're going to do that analysis in this process. And finally, in order to do it all with stakeholders and other individuals with expertise, meetings, either in person or virtual, would have to be carried out to plan for planned scheduling of this project. We're going to output a single document, which is the schedule management plan, one of the 10 subsidiary plans. That document would provide details on exactly how, by whom, and when the project schedule, the actual schedule, would be developed. And then once it's developed, how would it be approved? And then how would it be controlled? So things that go into the schedule management plan would include the units of measure, hours, days, weeks, or months, and that could be then used for measurement of the activities or decisions like efforts. So units of measure, level of accuracy. So what would be some acceptable variance on activities, plus or minus 2 hours, plus or minus 2 days? Or would we need the activities to be spot on, accurate? No, I suppose the larger projects would have some availability of some range of accuracies available to them, whereas smaller projects might need precise accuracy, precise estimation of activity duration. Sorry. We need variance thresholds. So, what are the amounts of delays that would be considered worrisome and then trigger corrective or preventative actions as defined in the risk management plan? So then we could also provide some slippage thresholds for the schedule. What kind of schedule methodology or schedule life cycle or scheduling tool is to be used? What kind of templates are to be used? What method for updating and for tracking of the schedule, for changing of the schedule is to be used? Is it something like tracking them only on phase ends or tracking the schedule weekly? Now, we also need to put some rules for measurements of the performance of the schedule. Is it earned value, which is the kind of emerging and the useful technique, or straightforward percentage completion method? And finally, frequency and format of reporting of the schedule performance.
Michael?
Yes.
When would you use variance thresholds? Would you use it within subtasks, or would you use maybe generally over a project that might be going on? Say if a project was going on 3-4 months, would you use variance threshold for the task, or maybe give it customize it later end?
I would imagine that it kind of depends on the project. You could make a decision that you provide some variance thresholds for activities if activities may have variances. If you have some levels of unknowns with activities. But I would say that for majority of the projects, variance thresholds should be put around milestones at least, high risk activities, and then the deadlines.
Right. Can you build them in a Gantt chart, that type of thing as well?
Yes. So part of this process is actually providing contingency reserves for each of the activities that have some risk associated with them, risks to the schedule. And one of the tools that we're going to be using is adding the contingency reserves to the activities. So that's going to be there.
How does a project manager kind of deal with that? And is it dealing with the subject matter expert in that area that gives them sort of a threshold that plus or minus could happen or mightn't happen?
Yeah.
Or
so I guess your question is to who would estimate these kind of the contingencies. It would be up to a combination between expert judgments, project managers. You can also use some of the probabilistic tools like 3-point estimates based on I think it's beta probability distribution. So you can come up with the optimistic, the pessimistic, and the optimum or kind of expected duration, and then use that for your time determination. But I would say that it would be up for discussion more than anything.
Right. Okay. Yeah. Thank you.
No bother. So once we have the plan for how we're going to plan the schedule, we can get after planning the schedule. And the first step is to define what are the activities, the things that we need to get done for this particular project. You know, the real world, we have to get things done, and the practical schedule can be only as good as the activities that that have been identified. Obviously, we can miss out on the activities, and that would mean that the schedule is less practical and less realistic, because in the process of coming up with the schedule, we simply miss things that need to get done. So that might make the schedule ineffective, which might lead to some change requests and general headache further down the road. So the purpose of the process define activities is to attempt to identify all possible activities at a reasonable level of resolution, and then list them, then nothing else. In this project, people with technical knowledge and other subject matter experts would take out a work package from the scope baseline, so from the work breakdown structure or from the work breakdown structure dictionary, and they would list all the activities needed to finish that specific work package. So just that work package, nothing else. This kind of thing would be done for every single work package generated in the work breakdown structure, and that would put together a very detailed, comprehensive, maybe even near complete list of the activities needed to complete the project. Obviously, project manager might need different people for different work packages depending on the kind of expertise required. But as long as the expertise is there to identify the activities, we are in business. So each of the some experts would focus on some work packages, other experts would focus on other ones. And generally speaking, you'd still want, in the end of the day, a list of the things that need to get done in order for each of the work packages to be a success. And this process is fundamental. So if the activities are defined poorly, we can't expect project schedule success. So it pays to do this process justice and define activities as well as possible. Spend time on it, and obviously in the discovery life cycle based in the discovery like project methodologies like in Agile or Spiral, not all the activities are known in the beginning, but as the activities become apparent, they can become part of the backlog or part of the next release, and that kind of way the activities are continually included into the process. Again, activities need to be defined well so the project schedule can be practical. We're going to deal with 3 inputs. We're going to use with 4 tools and techniques, and we're going to output 5 different items out of this process. Focusing on the inputs, we're going to use project management plan, and mainly this consists of components of schedule management plan, so instructions that were defined in the previous process telling us how work packages and work package deliverables are to be converted into activities and who should do that. And obviously, because we need the work packages themselves, we are going to require the scope baseline so that the activities can be defined for all the possible all the work packages. And also, scope might provide some inputs about constraints, some milestones or risks, and so on. Might be important for the identification of activities. Some of the EEFs, the enterprise environmental factors, can provide external factors related activities, things connected to compliance, to certain standards or regulations, things connected to cultural nature of organizations, especially in a cross-cultural project environment. Good example would be to understand if your project is carried out in Japan, it would be nice to understand the rituals that Japanese individuals would want to follow, like the business card exchange and so on. So it would be important to identify the activities that are culturally related. And finally, OPAs obviously include things like checklists for the activity creation and identification, lessons learned from the current project if this activities identification is carried out at further stages in the process or from previous projects of a similar nature, processes for decomposition and naming conventions, and so on. Anything that would contribute to meaningful activity definition. 4, tools and techniques. Starting with expert judgment. So people with knowledge and expertise that can contribute to successful, detailed, and meaningful decomposition of work packages into activities. This pool of individuals could include technical experts, domain experts, analysts, consultants, vendors, and any other stakeholders really that can contribute to the process. The key technique for this is decomposition, and essentially that's a fancy name given to breaking down work packages into activities. That technique was also used in the process of creating the work breakdown structure, where we broke deliverables into sub-deliverables. But now we're going to break deliverables and sub-deliverables into activities. So from nouns, we're going to move into verbs. And that's going to help us identify and document every activity that we can think of at a given time. Now, not all process projects are waterfall-like, so sometimes in an evolutionary or iterative-like project life cycle, the entire work breakdown structure is not available up front because it's only being discovered as the project progresses. So the work breakdown structure would be decomposed progressively as the work packages become more apparent, which is popular in agile or other adaptive life cycles. So I guess the deliverables, some of the deliverables would be decomposed initially, and then just those, some of the deliverables would be decomposed into work packages rather, and then those work packages would be decomposed into activities and then executed and so on. And then the other deliverables and the other work packages would be visited later in iterative cycles, and that's this idea of rolling wave planning, which is really a very generic term which covers kind of looped iterative and evolutionary life cycle where the work packages become apparent as the project progresses. So as an output for this process, we're going to create most important thing out of this is the activity list. The activity list is essentially the list of everything, all the actions that need to be done in order to complete this project. And that list is, again, the work packages decomposed, put together in such a way that there's some sort of a summary tasks, some phases, some milestones listed, and so on, so that there is some degree of structure to the activity list. Together with the activity list, we're going to put together activity attributes that become apparent as we think about the activities. And if those attributes become apparent, they can be recorded. So things like what kind of resources are going to be needed for the activity. Is there any specific sequence for that activity? Are there any regulatory requirements? Are there any constraints around the duration? Are there any risks, and so on? Obviously, not every activity is going to have that, so it's not necessary for every activity to have an attribute, but you'd expect that most of them would have at least some, and those that are identified should be documented. like if you had a project in real world, probably the activity list and activity attributes would be part of the same document that would be, would be separated into two different things. But it's important to understand that the list and the attributes are two different outputs of this process, so that the project managers can produce both of those outputs, let's say. We're going to identify some progress points for our project. So the milestones, and as it, it's kind of self-explanatory, because in a real world, milestone shows you exactly how far have you gotten in your journey to your objective. The schedule milestones are put here and there in the schedule baseline to control for comparing progress against the baseline during the project execution. Milestone is not an activity. No resources are allocated to milestones, and milestones have no duration. The duration of a milestone is 0. This is the convention that we should follow in putting together our schedules. The milestones usually mark completion of a phase or a given group of activities, like in the example over here. Project is relocation. You have collecting of requirements, getting the location, and remodeling. So each of those groups of activities is concluded by a milestone. So milestones can be optional, which are the ones that are included by the project manager and the manager team for tracking purposes only, and for better resolution of the project tracking. But some milestones are mandatory, and those mandatory milestones are provided by senior management, customers, or regulatory bodies listed in terms in the contract and the key stakeholders of the project. So these are at mandatory milestones, the key stakeholders are definitely going to want to have a look at your project, because it's the place to check it. Change requests have been raised to change scope or other baselines, because maybe more work or that was early missed may become apparent during the composition of the process, and you may have to, because of those change requests, and end up updating schedule baseline and the cost baseline. I did list activity attributes already, so I mentioned that, and I mentioned milestones. So once we have the activities listed together, we're going to have to sequence them. So to sequence, once they're identified, obviously they can't be done together at the same time, and they can't be done in a willy-nilly manner without any rhyme or reason. So they have to be done, they have to be sequenced, I suppose, in such a way that the way things are done, activities are completed, is corresponding to actually what would happen in reality. And the kind of purpose really to sequencing is to bring some logic and some order of doing things during execution of the project, and to optimize efficiency of the project execution within the project constraints. And because in sequencing activities, we're going to develop a logical relationships, we're going to have to know what the types of relationships out there. And there are 4 common ones. So we have finish to start. And in finish to start, which is shown in the first diagram here. Sorry, 1 second. In this diagram here, activity A should finish before activity B can start, and that's most common relationship. A good example would be lay foundation, or if you're building a building, let's say, activity lay foundation and build pillars. So laid foundation must finish before build pillars activity can be started. Second type, we have finish to finish. So activity A should finish before activity B can finish. So for instance, if we have two activities, one example would be handover of some software products, and second activity would be training of users. I guess the handover of software product cannot finish till training of users of software product is finished. We also have start to start, which essentially tells us that an activity, an activity should have started before some other activity can start, and it doesn't always mean that they start together. So, for instance, campus hiring or hiring process, and the second activity would be induction. Now, obviously, the induction can only start after hiring has started, and they are related to each other by their start dates. And last one that I have is start to finish. And this is the kind of, I guess, a little bit tricky one, and I don't want to focus on this too much because it's very rarely used, and there is no reasonable example that that I can provide you, and I would recommend that you refrain from using it. And it's kind of really useful for backward scheduling. So if your scheduling of your project is worked backwards from the end date towards the beginning, which is probably not the best thing to be doing. And if you're doing projects that have done this in the past, tend to be delayed, I guess. The real projects should do forward scheduling and tend to use this finish to start, start to start, and finish to finish relationships. But Project Management Book of Knowledge lists the 4 types, so you need to be aware that there is start to finish relationship as well, but I'm not going to spend time on it because it's not really corresponding to the real world. Anyway, these are the 4 relationships that we would use for activity scheduling and sequencing. And if you think back on the task that you had to do in the lab, part of it was building relationships, building dependencies between the activities, and that's exactly what this section of the lecture is related to. All right. Now, in this process, we are dealing with 4 inputs. We're going to produce the activity sequence using 4 tools and techniques, and we're going to output 2 items. The inputs include project management plan, which provides the schedule management plan and scope baseline. The schedule management plan that gives a little bit of detail on the life cycle methodology to be used, the people who are to be involved in sequencing. Is there a specific scheduling tool that has to be used? How is the relationships? How are the relationships between activities going to be verified, and so on? Whereas scope baseline may provide some references or assumptions or other relevant sequencing information that can be used to develop logical dependencies between the activities. We're going to input some project documents. The key ones are the activity list, the milestone list, and the activity attributes. All of those documents should provide an input into the sequencing. So an example would be if you have some activities that are related to a regulation, you may have a resource that has to undergo 20-hour safety training, and then the sequencing would need something like certification with a finish to start relationships to regulations. So you have to finish the certified safety training before you can be before you can be certified through the regulation. Assumption logs may provide assumptions regarding to the sequences of the activities. Like if the I don't know, if the office is being moved from one place to another, you assume that the furniture is going to be worked on 2 days after the site procurement or something like that. So if that assumption was different, then the sequencing of the activities would be different. So assumption log might also provide some information about this. As always, you're going to use enterprise environmental factors. So availability of software, availability of expertise, some industrial practices for sequencing, and organizational process assets like portfolios with projects, programs, and the list of dependencies that are already known, and templates, if there are any. Tools and techniques for this process include, most importantly, the precedence diagramming method, also dependency determination and integration, leads and lags, and finally project management information system. So we're going to start with precedence diagramming method, which is a fancy name given to activity network diagrams. And this is a well-worn engineering tool used since well, probably since way before I was alive anyway, late 70s, early 80s, and so on. Back then there was no software, so activities were literally put on paper, stuck to a wall, and then arrows would then move from one activity to the other, from the start of the project to the project end. Now we have a Microsoft project for it, so it's much easier to do it. Most of the network diagrams used in project are called activity on node, and that's because the nodes of the network diagram represent the activities and the arrows represent the dependencies in the relationships. So as in the example, we have start to finish dependency here, we have finish to finish dependency here, and we have finish to start dependency between A and D. You can see that all four types of the relationships in this all four types of the relationships in the activities, starts to finish is obviously least used, and Microsoft project uses the rules of the sequencing and scheduling to present the schedule based on the kind of assumptions and the models and the sequencing relationships that you came up with. And then we're also going to use dependency determination and integration, which is kind of like a technique which helps us to figure out what mix of relationships would be best suited for activities. And already we looked at the four possible relationships: the finish to start, start to start, finish to finish, and start to finish. And then, within this activity, we're going to see which of those dependencies is the most real life-like. The dependencies can be either mandatory, so they must be like that, or they can be discretionary, so they should be like that, based on internal rules and procedures or external regulatory requirements. So the four different relationships, four different relationships or dependencies for activity could be essentially listed as mandatory, external, mandatory, internal, discretionary, external, and discretionary internal. And I suppose other than this kind of dependencies, we're also going to look at leads and lags that can be applied to the schedule to make the schedule even closer to reality. It's kind of straightforward enough, really. So lag is the amount of time a successor activity has to be delayed after the predecessor activity. I hope it's clear that predecessor, if you go in your diagram from left to right, predecessor is to the left and successor is to the right. A good example would be curing of cement for any civil construction engineering projects. So let's say, for instance, for a bridge, the cement pillars are erected, and then some slabs are put on top to connect the bridge into the pillars. But if you erect a pillar and put the slab on top of the pillar, then you will have a big trouble because the bridge will disintegrate. So you need to wait. You need to wait some amount of time, depending on where it is and what kind of cement you're using. Let's say 15 to 20 days before you can mount slabs. And this amount of time that the loading, putting the beams or putting the slabs over the pillars is lag. And the relationship between those two activities would look exactly like that. You have a construct pillar, then you have the relationship, so that's finished to start, and then you have the lag listed on the relationship. So lag plus 15 days. Another example is painting. Painting a wall. If you put a primer, you have to wait for about 2 days for the primer to cure before you can paint enamel on it. And if you paint without that lag, then you'll be in trouble. The enamel or the paint won't lay properly. So that's lag. Lag is the delay. Lead, on the other hand, is a situation where rather than waiting before you can start the successor activity, you can overlap predecessor and successor. So if lag is delayed, then lead is overlap. If a succeeding activity can be overlapped with preceding activity, you can gain some time, and that would do the trick in the real world. So on an example, say if you are putting together some concrete cemented floor for a room, and you put marble tiles on the top of that floor, technically speaking, activity of cementing has to be done, and only then the tiling of the floor has to start technically, but you don't have to finish the cementing of the floor before the tiling can start. So tiling doesn't have to be completely dry. Cement doesn't have to be completely dry for tiling. Won't affect the quality. So you can overlap tiling with cementing. In another example, if you are building some toys, you would have to supply the inventory to make the toys. Let's say this would be activity of supplying the inventory, and then only once your inventory is supplied, you can start the activity, but you can continually supply the inventory as you're manufacturing the toys. So even though the inventorying has to be done in advance, you can start the manufacturing as soon as the inventory is in place, and you can overlap those two activities. Lead and lag, final dependency, I guess, type that would make the sequence of activities more meaningful, and that's kind of the activities have to be analyzed for the overlap once they're sequenced, overlap or delay. As an output, we're going to put together the project schedule network diagram and some document updates. The main purpose is to have almost all activities properly related to other activities, and then have them in a logical and practical sequence of doing work in a given project. And normally, if that's there, it's called the project schedule network diagram. And that's it really for this. Obviously, because you spent a lot of time analyzing activities, you may have to update the activity lists, the activity attributes, some of the risk registers if any risk factors become apparent or the risk contingencies are needed. And that's it for part 1. So let me stop the video recording right here.